Hi, we're Team Epic. My name is Heather Towey. These are my teammates.
I'm Ben.
I'm Elvin.
I'm Annie.
And I'm Evan.
And we created an automated emergency response in EpiPens. So the number of food allergies in the U.S. among children and young adults has increased by 50% from 1997 to 2011. And food allergies is the #1 cause of anaphylaxis, which is a deadly allergic reaction that kills 150 children and young adults each year. The first case of treatment when anaphylaxis occurs is a drug called epinephrine, which can be administered through the use of an EpiPen. And the diagram shows how to use an EpiPen. It's very simple. You remove the blue safety cap, press the yellow tip into your thigh until you hear a click. That'll let the needle in. You hold for 10 seconds and then massage the area to make sure that the medicine is in. But it's imperative to call 911 after the use of an EpiPen, because an EpiPen doesn't stop the process, it just slows down anaphylaxis until medical help can arrive.
Our customer for this project is Professor Pisano, and his motivation behind coming up with the idea is that his grandson has food allergies that require whoever is taking care of him to carry around EpiPens. So the concern in that situation is that if you're with a child and you need to administer an EpiPen, you'd rather take the time to take care of the child than perhaps having to go into another room to call 911. Another situation that could arise is if you're alone and you have to administer it to yourself, then you may be physically unable to call 911. So that's where the EPIC case comes in. For our prototype, we've made a completely autonomous case that calls 911 upon the use of an EpiPen. So it doesn't connect to your cell phone or any other wireless device. It calls it completely on its own. It also gathers GPS coordinates and sends the exact location of the incident to 911. The case comes preloaded. We were thinking that if we were a business, the customer would order it from us, and when they go pick up their EpiPens, it would come the case would come preloaded with all of their emergency contacts. So also upon the use of the EpiPen, it'll text the emergency contacts, what happened, the name of the user, and where it happened. In our prototype, we also included exception handling, which I'll talk about a little bit later, and there's a self-test battery feature as well.
So our system consists of two main components. There's the case, which holds the EpiPens. Most people who carry around EpiPens always have a case for them. And the cap, the safety cap, which when removed allows the EpiPen to actually be used. The case does most of the work. It consists of a main controller, which in this case is a Raspberry Pi, a GSM chip, which is used to actually make the phone calls and send the text messages, and a Bluetooth chip, which is used to connect to the cap. Also, GPS chip, which is used to locate where the user is, and batteries. The cap itself is just batteries, or one single battery, and a Bluetooth chip, which allows the cap to basically hail the case and tell it that the EpiPen has been injected.
As far as power is concerned, one of the customer requirements was that the system be battery powered and that these batteries must last for at least a month without being recharged or replaced. With the Raspberry Pi current draw around 300 milliamps constantly without a low power feature, this meant that we would either have to use a very large battery or think of something else. So the way that we got around that is that we decided to make the system only turn on when the case is opened. This way, when the case isn't being used, no power is drawn from the batteries, and they're preserved for the lifetime of the battery. Once the system is turned on, it's powered by 4 AA batteries regulated to 5 volts and draws 500 milliamps. The case also includes a battery test voltage circuit that indicates to the user when the battery voltage is dropped below a certain level.
So in order for the case and the cap to communicate, we use Bluetooth chips. Basically, we don't want to draw power at any time unless the system is actually used. So on the safety cap, we actually don't connect the battery until the cap is removed. So when the cap is removed, the battery goes into connection with the Bluetooth chip, and the Bluetooth chip begins emitting its MAC address, and it makes it essentially pairable. Then the case itself, when it's opened, is constantly searching for the correct Bluetooth chip. We have a unique identifier for each chip, so it's looking for the cap, and if it finds it, that means the EpiPen has been used and it needs to begin the call process and finding, or well, it's already finding GPS coordinates, so it begins the call process.
So our main goal in this product is to have medical services arrive at the scene as quick as possible. And one of the hurdles of this was the GPS chip. The fastest chips that we could find was about 30 seconds cold start time, which means that it's going to take a while for the chip to get its coordinates. So regardless of whether the EpiPen is used or not, when the case is open and it turns on, the GPS starts looking for coordinates immediately. And also, for a connection type, it uses USB. This way that the Bluetooth and the GSM module can interchange between UART while the GPS is always looking for coordinates. Other stuff was the operating system, the operating current of the GPS is nice and low. This way it can keep on running without draining too much battery, and the voltage required fits well in with every other module that we have.
So to achieve the main purpose of the project to make the phone call, we use a GSM chip. So our chip was a SIM900 GSM/GPRS module. And to conserve costs, because with a SIM card plan, we use AT&T pay-as-you-go. So this offers the cheapest solution for the customer, since it's only being used at an emergency. Each run, so a call and text messages, depending on how many texts you send out, it's about like 50 cents. So the cost is nice and low for each emergency contact. It communicates serially, so it'll just send AT commands, and when the case is first turned on, the GSM chip will not be turned on until the Bluetooth is found, and this is one way to prevent false positives, so that if the case is opened and there is no emergency, 911 won't be called until that Bluetooth chip is removed. So it'll place the phone call to 911, and a automated message will be played on loop for a minute with the GPS coordinates inside, and then it'll also send the text messages with the time that it was used and the coordinates as well.
All right, so you just heard about all the separate modules of our project, and I'm going to talk about how we were able to bring them all together. So we have one main Python script, and it's executed on boot, so it's executed when the case is opened. So the sequence of events that happens when the case is opened is that first it sits there and is waiting for the Bluetooth signal from the cap to let it know that the EpiPen has been used. At the same time that it's sitting there waiting for the Bluetooth signal, it's also gathering the GPS coordinates. Once it has the Bluetooth signal and it knows that the EpiPen has been used, it creates a unique distress message at runtime, including the user's name and the coordinates of the incident. And we're able to use a command called eSpeak to say that out loud, and we have a simple audio connection between the Raspberry Pi and the GSM chip that plays it on loop. So we did our best to make sure that all of these things would work as planned, but obviously since it is a medical device used in an emergency, we had to make sure that if anything were to go wrong, that we handled it. So one of the things that we saw that sometimes goes wrong is that the GPS chip didn't gather coordinates in a timely manner if we were inside. So what we did was add a GPS timeout feature so that usually before you make the call, you need the Bluetooth signal and the GPS coordinates. But if it didn't get those in a certain amount of time, it makes the call anyway. And it lets 911 know that we weren't able to obtain the coordinates and that they need to triangulate the call. And we have, when it places text messages or phone calls, we need to have a way to have the users know that it was placed successfully. Because one of the worst things that could happen is if they're sitting there thinking that help is on the way when in fact it is not. So when the call has been placed successfully, a green LED lights up. And if it was not placed successfully, a red LED lights up in the same exact location to let them know that they have to find other means to contact emergency help.
So this is just a demonstration of the case and working.
This is a demo of the battery test feature. The green light indicates that the battery levels are high. Once the case is opened, the power light turns on and the case waits for the Bluetooth signal from the cap. Here Ben removes the safety cap from the EpiPen, which then sends a Bluetooth signal back to the case. The red and green lights show that the system is still booting up. Once they turn off, our main script is executed. In this script, GPS coordinates are obtained and serial commands are sent to the GSM chip to make the phone call and send the text messages. This is an example of what the 911 operator will hear. After the call has been placed successfully, the green LED will light up on the case. This is an example of what one of the text messages would look like.
So we just want to send a special thanks to all the senior design staff and Tom, who helped us with the 3D printing of the cap for the Bluetooth holder. So you can go to our table during the demos, and we can hopefully show you how it works, and if you have any more questions. So we'll open the floor up to questions now.
Primary way of using like a cell phone, just attaching the Bluetooth to something communication there to get the signal out of my phone.
Sorry, so to get the GPS coordinates without having service?
Right, basically having like your existing system looks like a good backup, or like the primary method, like you connect my phone, use my assisted GPS here, which is way more accurate than the.
Well, if you had your phone, you could use it to call 911 as well.
This was supposed to be a standalone system.
Right.
This is supposed to be a standalone system, for example, if you don't have a phone. If you're a child and you don't have a phone on you, so you're carrying your EpiPens and something happens. Also, it was just supposed to be standalone, so that if you don't have a phone or you can't access a phone, the case will do everything for you.
Okay, I got you.
What happens if you're in a building that has like 10 floors and your GPS location gives you exactly where you are? Is there another way that 911 can contact you to figure out exactly where you are?
Well, for one, there would be included callback numbers in a future version, and also GPS can give height. So if we were to, in future versions, like make a conversion between height and floors, however, GPS tends not to work well indoors, so it might not be as accurate.
So yeah, the GPS chip we use does give latitude, longitude, and altitude. So we have all three of those numbers. We just sent latitude, longitude.
You guys actually work with emergency services to confirm that if they receive this automated phone call, they would know what to do?
Yeah, that's a really good question. I've been in contact with BUPD, and they have an emergency phone number that you instead of 911, you can call their emergency number. So I was talking to them a little bit, and they said that I was like, if you got an automated call, would you just hang up automatically and think it was bogus? And they said, no, we listen to every single call no matter what. And I said, is this an okay way to give location, just the latitude and longitude? And they said, obviously talking to someone to confirm exactly where they are is the most ideal, but they're like, in a pinch, we could obviously, yeah, we could figure it out.
Oh, yes, okay.
I can think of a rare situation where you wouldn't want to call 911. Someone's in distress, EMTs are already present, and then they decide they're going to use the EpiPen. Do you have any way to disarm the calling that is hard to do, but not impossible to do?
Well, ideally, we don't want to stop the call in case, it's better to have them come just in case there is something wrong. But the LED that determines if the call was placed successfully or not, if it hasn't lit up yet, that means that the call hasn't been placed. So if you close the case and hit the reset button to turn the system off before that happens, I'm pretty sure you can time it well enough to stop the call.
Second question is, your whole idea would work well with a whole lot of other things, like for elderly people wearing appendage and all that sort of stuff. So just something to think about.
Yeah, we actually have been thinking about that a lot, and I don't know, you probably have all heard of Life Alert. So what sets us apart from them is that we call 911 directly, whereas systems like that currently go through a third-party call center. So yeah, we've been thinking about expanding to those sort of applications as well.
Okay, thank you.